Hi, my name is Joe. I'm a technician here at New Life Scientific. Today we're going to talk about a topic that doesn't have a lot of information out there yet, especially in depth how this unit works. So we're going to talk about how this Revco Ultima Plus negative 80 degree freezer, negative 80 degrees Celsius freezer works in a decent amount of depth. So first I'm just going to kind of touch on the components real quick, what they are, and then we're going to go through and talk about how it works, and at that point we'll kind of delve more into the components and how they work. But of course, this is the control panel. I'll kind of go through the system here, start to finish. Oh, one thing important to note about what they typically call ultra low temperature refrigeration, but that term can mean a lot of different things. But specifically when discussing these types of freezers that get to the negative 80 degrees Celsius, there are usually two separate stages of refrigeration. There's stage one and stage two. Stage one, its only purpose is basically to get stage two condensed into a liquid, cooled, so that it can do it does the main work of actually cooling the unit. So that's one thing really unique about these is the two-stage. It's called cascading refrigeration, and that's what's really unique about these that makes it a lot different than your normal freezers or air conditioning in general. So real quick with some components. Stage one, we'll kind of talk about stage one components first. They're generally, stage one and two are very similar, but there are some differences. So this is the stage one compressor. And I don't have the cover off of it. Actually, I'll take the cover off for you right now. It's not overly important, but it's something nice to know, because some of you may have experienced compressor failures, and sometimes it's just the capacitors. So these compressors usually have two capacitors. There's a start and a run capacitor that have to be on these units to make the motors function correctly. And sometimes they go out. So as the compressor, we have, let's come over here. We have the condenser. This is the first stage condenser. It does also do a little bit with the second stage, but it's pretty much mostly first stage. We have the first stage filter dryer, and we have up in here, you can't see it, but it's kind of generally called it's called a heat exchanger. It's where the first and second stage meet, and it's a component that's kind of shared by both the first and second stage. And we have here an accumulator or expansion tank. Like I said, I'll talk more about what these do in a minute here. That's pretty much most of the first stage right there. I mean, obviously there's the tubing that connects all the parts, but that's mostly what it is. Oh, and of course we have the condenser fans, which pull the ambient air across the condenser. Very important also. And I want to show you a little bit of the electronics. This is kind of a lot of this is where some of the logic takes place, where it takes sensor input and whatnot and makes decisions, turn this on, turn this off. This is mainly your power board. So this is really its main job is to supply power to fans, compressors, stuff like that. And you have your incoming transformers and a DC power supply. Here is your 12-volt backup battery. So when your unit loses power, this battery only runs the controls, like the display and whatnot. It can't actually run the unit altogether. There would need quite a few more batteries than that. But it does keep the display on. It tells you temperature, keeps the alarms on and all that, so you can kind of track what's going on inside until you get power restored. It also kind of tells you, if there was a power outage, the alarms will still be on when you come in the next morning or whatever. That should be about all for the first stage. And of course, here's your little battery switch. So when you turn your freezer off on purpose, when it doesn't go out, but when you actually unplug it or turn it off for whatever reason, you turn that off and it keeps the battery from draining as much as it would. Now for some of the second stage components. For the second stage components, we have, of course, the compressor again, and the two capacitors. The compressors are essentially identical to each other. And there's a couple different, there's one component here I'm going to show you that's, it's one that's sometimes not on the first stage, but it's almost always on the second stage of these freezers. It's the oil separator. We'll talk about that more. So that's one that's almost always on the second stage, not so much on the first stage. We have that also. As I said before, the condenser, again, the second stage does share a little bit of that condenser with the first stage, just a small amount. We have the filter dryer, again, much like this one. They're pretty much identical as well. This is the second stage as filter dryer. And we have, we noted on this one had an accumulator or an expansion tank. This one kind of has sort of two of them. This is kind of the mini one, and this is the main one. Expansion tank, it's really big. It kind of allows you to have a good amount of extra refrigerant capacity, and also prevents liquid from going to the compressor. We'll talk about that in a minute. And second stage has this little valve that controls the flow from here. So if it doesn't, I believe when it's off, it opens up this system and lets this completely interact with the rest. When it starts, it closes, and then sometime during the operating cycle, it opens up again. But another, obviously an important part here. So you have the filter dryer, but then we talked about the heat exchanger up here. So remember, the first and second stage share this component up in here, which I could show you, but it's buried underneath like 5 inches of foam. So there's also that, which is shared. And then all around this compartment, there are coils of copper tubing that's where the refrigerant evaporates and cools, and we'll talk about that too. Okay, I think that's just about everything major component-wise for this. Now we're going to kind of talk about how it works. As I said earlier, I believe the first stage only job is to cool. It's to remove heat from the second stage. So all the components in the first stage we talked about, its goal is to get up to here, to the heat exchanger, and extract as much heat as possible from the second stage that we talked about. So what will happen during the operation, first stage comes on, this compressor kicks on, it takes the refrigerant in a gas state and it compresses it. Depending on the model, a lot of times it's around 150, 160 psi. It changes with temperature. When it's operating normally, sometimes it's lower hundreds. But it compresses the refrigerant gases and it sends it, let's see if I can make it this way. Yes. It sends it to that condenser we talked about. So first stage compressor compresses the refrigerant gases, sends it up here. And when it comes here, the gases are extremely hot. Well over 100 degrees, maybe 130, 150 degrees, depending Fahrenheit. It comes through here, and there's a bunch of coils of wire that go back and forth, and they're attached to these fins. And the fans we talked about, they draw heat, they draw ambient air through the fins and cool off that first stage refrigerant as it comes through. It turns it from a gas to a liquid. That's why it's called a condenser. It condenses it to a liquid. So it comes out of here in a liquid state and cooler than when it came in. After that, sorry, it's a lot of a lot of turning here. Okay. Yeah, we talked about that. So yeah, so this is where it comes in. It goes through these tubes that we talked about, and it comes out here. There's things like high pressure cutoff switches to where if the pressure gets too high, it kills the compressor to protect it. It then comes to that filter dryer we talked about. This is a liquid line filter dryer, so the refrigerant should be in a mainly liquid state when it comes through here. It filters out small particles like metal, metal shavings, very, very small dirt and other debris that might get its way in there at some point while servicing or manufacturing. And very importantly, it removes moisture from the system. It traps water in there, and it can remove acid from the system. Not a lot. So if there's a compressor failure and it's electrical, a lot of times the system will get really acidic. But barring that, under normal operation, this thing takes a good amount of the acid out of the system that might develop over time. After it goes through here, filters out the contaminants, it comes into this capillary tube. I guess I should have probably mentioned this too in the component area. But this capillary tube is essentially a metering device that controls how much refrigerant flows into that heat exchanger we talked about. So it comes in here in a liquid, still under a decent amount of pressure, and it comes up through the capillary tube, up into that heat exchanger we talked about, and then it goes into a decently large volume. At that point, the pressure drops way down, and the liquid refrigerant evaporates again and sucks all the heat out of that chamber that it's in. And that chamber, like we said, is shared with the second stage. So the heat that the first stage is taking out by doing that is coming from the second stage. So it goes in there, evaporates, cools down, takes all the heat from the second stage, and then it comes back out, and it comes down into this accumulator that we talked about earlier. The accumulator, it's a way of storing excess refrigerant, especially a liquid. So this is a way of increasing some of the capacity of the refrigeration system, and it's very important for preventing liquid refrigerant from getting back into the compressor. Because if liquid refrigerant gets into the compressor, it can destroy the compressor. A lot of these have a safety to where if liquid does get in, the compressor will start to have a harder time compressing, and it'll draw more amps, and it'll actually cut the compressor out because it has like an overload, basically an overload protection built into it. But it'll come right back on once that overload switch cools off, and it'll just keep doing it. So it will eventually hurt your compressor or destroy it. So it's really important to have these devices in these because it prevents liquid from getting back to the compressor on the suction side. So it comes through here, the liquid stays, the gas passes through and goes back into the compressor. So this is where the gas comes out and the gas comes in back here after it's all done. And then the liquid sits in here, and once it evaporates, it carries on back into the return line. That's the first stage. On the second stage, it's much the same with a few differences. So here's your second stage compressor. Here's our outlet, or our high pressure side where the gases are compressed and sent through here. They also pass through the condenser, but only about in one row or so. They don't have quite the same attention that the second stage gets in there. So they do pass through here too, but this, like I said, this is mainly for the first stage, but the second stage shares it a little bit. It comes out and it goes into this oil separator that wasn't on the first stage. So this component actually separates the oil, which intrinsically it's part of the design. It gets sucked in through the refrigerant in the system and it passes through. So this, when that refrigerant gas comes through, it has oil in it. So this component filters out the oil, which it's important because the less oil you have in your refrigerant when it's going to do its job up there and evaporate, the more actual refrigerant you can fit in the lines. Because if it's filled up with, if the refrigerant's mixed in with a bunch of oil, you're not getting as much refrigerant in the line. And as you get into tight spaces like the capillary tube we talked about, the oil can kind of cause restrictions because it's thick and it gets really viscous, especially when it gets cold. So on the second stage, when you're dealing with really low refrigeration, it separates out the oil to prevent those things from happening. So coming out of here, you should have pretty much, for the most part, oil-free refrigerant in the gas state, or yeah, it should still be in the gas state. It comes up, oh, it actually, and also, interesting little thing, it touches this component. This is another one of those expansion tanks we talked about. This is the return from the second stage after it's done up here. It actually kind of uses some more of its cooling capacity to cool off this line when it's coming up and to heat this up. So basically, this component takes heat from this line, which helps cool this off, which is what we want to do, and which helps heat this up because we want to make sure there's no liquid, remember, getting back in the compressor. So it's kind of a twofold thing there. It goes up in here, and at this state, it could very well be in a liquid state because it comes up through the, up here into the filter dryer again, the liquid filter dryer, liquid line. Also, it's filtering out the same things again. It's filtering out metal particles, dirt, moisture, acids to a degree. And then it's coming up through here, up into that heat exchanger we talked about, where the first stage is taking heat away from the second stage, making sure it condenses, and not only condenses, but gets really, really cold. So this up here will often reach negative 50 degrees Celsius. And this reaches negative 50 degrees Celsius. And then once it comes up, the second stage, it keeps coming up through after that. And at that point, it's a liquid at negative 50 degrees, roughly negative 45 degrees Celsius. And then it goes into those tubes that we talked about that are spread all inside here on the top, sides, and whatnot. That's where the refrigerant, the liquid refrigerant, evaporates and sucks all the heat out of the chamber. And those temperatures, up to where it evaporates, it reaches negative 90 degrees Celsius, negative 90-some degrees Celsius, depending on the situation and temperatures and things like that. But it's extremely cold. The first stage system can only get to about negative 50, and the second stage can get down to about negative 90 or so Celsius. So after it's done cooling off and taking all the heat out of the inside, it comes back down through this line. And once again, this is kind of like a liquid trap. So in case there's any liquid refrigerant that got through and didn't evaporate up here where it was supposed to, this will kind of trap it. And the gas will continue on through back to the compressor, but this liquid will sit here until it evaporates, and then it'll come back through. Another component, we talked about another expansion tank or accumulator. This holds extra refrigerant that gets released at a certain time or temperature. Like we talked about, when this thing first starts up, this closes. It doesn't let any refrigerant come in or out. And then once it reaches a certain temperature, it can open again, and it'll let the refrigerant come back out to give the freezer some more cooling capacity when it needs it to get that extra few degrees to get it really cold. It's just kind of a way of storing extra refrigerant until you need it, because you can't have it all in the system at once. It would cause pressures to be too high. see, that's mostly everything with how it works. I know it was a lot in a short period of time. It's kind of complicated, but at least now you kind of have an idea. There's two separate refrigeration systems. One cools the other. Yeah. Let's see. No, I think that's all. Hopefully you got a little bit of an idea of how these things work and what the components are. Obviously you won't be experts on it. No, I'm not either, but you'll have an idea now, kind of when things go wrong and what's going on. Thanks.